Hello my dear students, in this lecture we are going to see interaction of radiation with matter. Now the way of interaction of any radiation with matter, that we are going to learn here. Now matter is nothing but it may be a solid state or it may be a liquid state, it may be a gaseous state also. Now with all these matter, how the radiation is interacting, that we have to learn in this particular video. Now my dear students, whenever there is an interaction of matter with radiation or radiation with matter, then there are basically three ways. That is, first is stimulated absorption, then spontaneous emission, and then stimulated emission. So my dear students, in this lecture we are going to see these three ways of interaction of radiation with matter. So with this basic introduction to this lecture, let us start one by one. Now my dear students, to understand the interaction of radiation with matter, let us understand the basic model of atomic structure. Now my dear students, here the center is nucleus. Here the center is called nucleus for any atom. The center is called nucleus. And my dear students, in this nucleus, basically it contains photons and neutrons. Nucleus always contains photons and neutrons, that already you know. You have learned this in chemistry in school level also. And my dear students, the electrons revolve in these orbits. These circular directions are nothing but orbits of electron revolution, right? And my dear students, these orbits are given names. Here first orbit is called K, second orbit is L, then third is M, then there will be a N. After that N, the sequence will go on, right? And my dear students, every orbit is having some energy. Therefore, the energy level of first orbit is E1, that is K. The energy level of K orbit is nothing but called E1. Similarly, the energy level of L orbit, which is nothing but second orbit, is E2, and energy level of third orbit is E3, and so on. Right? For N, there will be an energy level of E4. Likewise. And my dear students, here there is a principal quantum number we call as a principal quantum number. Let us write down this principal quantum number which is represented by N. And my dear students, this principal quantum number is for first orbit, that is K, N is equal to 1. Then for L, N is equal to 2. For M orbit, N is equal to 3. For N orbit, N is equal to 4. So on, it will go on increasing by 1 in the step of 1. Here N is equal to 1, N is equal to 2, N is equal to 3, and so on. Right. And my dear students, here number of electrons, the maximum possible number of electrons. Right. What I am saying, maximum possible number of electrons is equal to twice N square. This is a formula to find maximum possible number of electrons in any orbit. Therefore, if I calculate maximum possible number of electrons in K, for K, N is equal to 1, therefore 2 into 1 square, there will be 2, means the maximum possible number of electrons in the K will be 2. Here 1 electron, another electron, right? These are the 2 electrons, therefore I will write here 2. Similarly, in this L orbit, now for L, N is equal to 2, therefore 2 into 2 square, that is 8. Therefore, the maximum possible electrons in L orbit are 8. Therefore, here I will write there will be 8 electrons. Similarly, for M, how many electrons will be there? Here for M, N is equal to 3. Therefore, 2 into 3 square, that is 18. Therefore, in M orbit, there will be 18 electron. And so on for N orbit. It will be for N is equal to 4. Therefore, 2 into 4 square, therefore 32. Therefore, there will be a 32 electrons in N orbit, and so on it will go on, right? And my dear students, as number of electrons revolving around this nucleus, here all these electrons are revolving around this nucleus. Now my dear students, here if number of electrons are less, it will be having lesser energy. Therefore, here K orbit is having E1 energy. Now as we go on, that is, as principal quantum number goes on increasing, the energy level also goes on increasing. That means the outermost orbits are unstable. Whenever energy is more, it is called unstable. Right? And whenever energy is less, then it will be more stable as compared to previous case, right? Now my dear students, here we can say in first orbit energy will be less as compared to in second orbit, as compared to in third orbit, and so on. Therefore, my dear students, here this E1, that is energy in first orbit, that is K orbit, is less than E2, is less than E3, and so on, we can say. Means as I go outside, there will be an instability, right? Because of higher energy, the electrons will be unstable. Now my dear students, let us understand this basic principle. Always naturally, what I am saying, naturally always the motion is always from high energy to low energy, motion from high energy to low energy. This is very basic funda. Always there is a motion from high energy to low energy naturally. Again, you might have seen the heat. Let us say the two atoms, let us say here temperature is T2 and here temperature is T1. What I am saying, temperatures that you have learned in school level also. Now let us say T2 is more than T1. T2 is more than T1 means temperature on this left side is more than temperature on this right side. That's why the flow of energy will be always from high energy level, that is E2 will be more than E1. As the temperature T2 is more than T1, therefore energy E2 will be more than E1. That's why the flow of energy will be always from high energy, that is E2 to E1. Means always heat flows from high temperature to low temperature, that you have learned in school level. The same funda will happen here. Naturally the motion of electron is always from high level energy to the low energy level. That's why the innermost orbit is most stable, because it is having lesser energy, right? This is the basic principle. Now my dear students, here difference in energy of two orbit. Now if I consider K and L, now the difference in energy of two orbit is E2 minus E1. This will be the difference of energy in two orbits, that is in K and L. Now my dear students, if I supply one photon of energy h nu, if I supply one photon of energy h nu, where you have studied this, what is the nu? Now my dear students, nu is monochromatic radiation frequency, right? Monochromatic radiation of frequency nu, right? Now here nu is nothing but frequency. Nu is frequency of radiation, we can say nu is frequency of radiation. Now here, if I supply one photon of energy h nu, then if this h nu is a difference of this E2 minus E1, then there will be a this electronic motion, right? Whenever if I supply external photon of energy h nu, where nu is a frequency of radiation, then because of this photon energy, if this h nu is equal to difference of this energy levels E2 minus E1, then there will be this electronic jump between orbits. Means the electron from lower energy level will jump to the higher energy level, or the reverse may take place, that is electron from the higher energy level to the lower energy level may jump. There may be jump in both direction depending on the principle. Now these jumps are classified as interaction of radiation with matter. These electronic jumps from one orbit to the another orbit are known as interaction of radiation with matter. Now, whenever any electron moves from lower energy level to higher energy level, then the process is called absorption. And whenever electron moves from higher energy level to the lower energy level, then the process is called emission. Right. So write down this. So here, if I draw the energy levels, let us say E2 is a higher energy level and E1 is lower energy level. Right. And my dear students, let us say in E1 there is an electron. Now, if I supply energy to this electron, for this electron, if I supply energy of magnitude h nu, that is a photon, I am supplying here photon of energy h nu. Nu is a frequency of radiation, right? And h nu is a energy of photon. Now we have already seen E1 is less than E2, means we are supplying photon of energy h nu to the lower energy level. Therefore, because of this, now this h nu is equal to of magnitude. This h nu is of magnitude. Let me write here, right? This photon energy is of magnitude this energy difference E2 minus E1. If I supply photon of energy h nu of magnitude of difference in energy level, then my dear students, this electron from the, this is the electron here, this is the electron, this electron from the lower energy level will jump to the higher energy level. Therefore this electron from the lower energy level will go to the higher energy level, and the process is called absorption. This process is called absorption, right? Whenever electron moves from lower energy level to the higher energy level, the process is called absorption. And if reverse takes place, that means whenever any electron moves from higher level energy, whenever any electron moves from higher level energy to the lower energy level, then the process is called emission. Then the process is called emission. And this absorption and emission is called as transaction. This absorption and emission is called transaction here, right? So let us understand this transaction. There are transaction or interaction. We can say transaction or interaction. Now there are basically three types of interaction, right? That is stimulated absorption, spontaneous emission, and stimulated emission. So these three types of transaction or interactions we have to understand here. So let us start one by one. So basically we have seen here nu is nothing but radiation frequency. This nu is radiation frequency or frequency of radiation, we can say, right? And my dear students, the energy in photon, we can say energy in photon is equal to energy in photon, which is E is equal to h nu, is nothing but h nu. And my dear students, here E2 is higher energy level as compared to E1, right? And here I am supplying the energy of photon, which is nothing but h nu of magnitude difference between these two energy levels, E2 minus E1. Now this is the process here. Now let us understand, with the help of this understanding, let us understand the first term, that is stimulated absorption. So first write down heading stimulated absorption. Now my dear students, in this stimulated absorption, let us say E2 is a higher energy level and there is a E1 which is lower energy level. E1 is a lower energy level, and in this E1, that is lower energy level, there is one electron, right? And my dear students, on this electron, if I supply a photon, if I give a photon of energy h nu, and this h nu is nothing but difference between energy levels, right? Then my dear students, because of this photon energy, this electron in energy level E1 will excite to travel to the E2. Therefore this electron from energy level E1 will jump to the another orbit and it will go to the E2, and the same process is called absorption. So here I have written the definition of stimulated absorption, that is, an atom in lower energy state E1 may absorb the incident photon and may be excited to E2. Means this atom in lower energy level will absorb the energy of photon and will travel to the higher energy level E2, and this transition is nothing but stimulated absorption. Now let us say capital A is atoms in lower energy state. Let us say capital A is atoms atoms in lower energy state, that is at E1, right? Now at E1 we can say atoms in lower energy state E1, and let us say A star be the atoms in higher energy state, that is E2, right? Now my dear students, here if I want to write the equation or balance equation, then the atoms in lower energy state A will absorb the energy of photon h mu and will go to the higher energy state, that is atoms in higher energy level A star. This will be the energy balance here, right? Or atom balance we can say. Now again, if I want to write one more equation, let us say the number of atoms as represented as NAB excited during the time del t is given by. Now here the number of atoms NAB excited excited during time period of del t, very small time period del t. Now if I want to calculate this number of atoms NAB excited during the time period del t, this is given as NAB is equal to, now here the atom is traveling from E1 to E2, therefore here the constant will be, here probability state is B1 to 2, right? Then N1 into q del t into q del t. This is the formula. Now I will explain this meaning or terminology. Now my dear students, here NAB is the number of atoms excited during the time del t, right? And my dear students, this B12 is nothing but probability of an absorption. B12 is probability of absorption. Now N1 is the number of atoms in state E1. N1 is number of atoms in state E1. B1 to 2 is probability of state absorption. Then Q, here Q is energy density of the incident beam. Q is energy density of incident beam, right? And then my dear students, delta is small time interval, right? Therefore this is how equation can be written. Now my dear students, in case of stimulated absorption, we have seen that, see, E2 is higher energy level and E1 is lower energy level. Now if I supply photon, that is photon energy, to the lower energy level E1, then the atom or electron from this E1 will go jump to the E2, right? That means the electron, now the new position of electron after absorption, this is the condition of after absorption, we can say after absorption, right? It is after absorption condition. Now the electron has traveled to E2. means this electron is in higher energy level. Now my dear students, but the electron always, or any atom always tries to move from high level to the low energy level, means this electron is at higher energy level, that is E2 is more than E1, but always the motion of any atom is from always high energy to the low energy, means this atom or electron is unstable here, right? Therefore this atom or electron will try to travel towards the low energy level, right? And my dear students, this travel of this atom or electron, travel of this atom or electron towards the low energy level is by two ways, right? There may be a spontaneous emission or there may be a stimulated emission. Now what is this exactly, we will understand. So my dear students, here this is called emission. This is called emission whenever the electron is traveling from high energy level E2 to the low energy level E1. Such a process is called emission, and this emission can be of two types. That is, first is spontaneous emission. The first is, we can say, spontaneous emission, or second is stimulated emission. Now spontaneous means natural process, spontaneous emission is natural process, and stimulated emission is force process. Now let us understand here. Now my dear students, generally in case of your bulb light, that bulb, electrical bulb in your home, that is having spontaneous emission, that is natural process, it is a natural process. But my dear students, in case of laser light, there is a stimulated emission of this electron or photon, right? Now let us understand what is this exactly. Now if it is spontaneous emission, let us understand first spontaneous emission, right? Now in case of spontaneous emission, this is a natural process, means without any external force, this electron, because of energy difference or because of excess energy, will travel from this high energy to the low energy. Now therefore we can say this is a natural process, this is a natural process. Now my dear students, as this electron is in higher energy level, therefore this electron will be higher energy, therefore this electron will get excited to travel towards the lower energy. And my dear students, this electron will stay in this higher energy level for very short duration of time, and the time duration is, here the time duration of electron is 10 to the power minus 8 seconds, and this is called lifetime of atom, right? This is called lifetime of atom in higher energy level, in higher energy level, that is at E2. Means whenever during the process of absorption, this electron from E1 will jump to the E2, but this electron or atom will stay here only for 10 to the power minus 8 seconds, and then again because of the energy difference it will travel to the lower energy level. And during this process there is an emission of photon. During this process there is an emission of photon. Now this emission is nothing but, that is energy of photon, which is nothing but Eh mu, energy of photon which is Eh mu, which is nothing but E2 minus E1. The same energy difference will be the emission here, and this photon is traveling here. But my dear students, this emission is natural, means this emission is scattered. This is a natural emission, or we can say scattered emission, right? Scattered emission. In first lecture we have seen such type of emission is called scattered emission, and such type of motion is nothing but a random motion. This photon can move in any direction, right? And my dear students, this is called incoherent. This is called incoherent, right? We have seen, and this will be having, it is not a straight line path, it is a scattered path, right? It will spread in all direction like your tube bulb, right? Now my dear students, again we have seen such type of emission is non-monochromatic. In the first lecture these all points we have seen, right? Now my dear students, here how to write the energy balance. Now here if I want to write energy balance, now A star, this A star was the number of atoms at a higher energy level, just now we have seen, is equal to, this will become, now here, now this A star is converted into number of atoms at lower energy level, that is A, plus some energy of photon is released here, that is emission, H mu, right? This will be the energy balance, right? Now again my dear students, if I want to write the equation for number of spontaneous transitions, that is NSP, let us say here if I write NSP, number of spontaneous transition NSP taking place in a medium during the short duration of time, during the very short duration of time, this NSP is written as, now here it is A221, that is from higher energy level to the lower energy level. A221 is a probability of spontaneous emission from higher level energy to the lower energy level, right? Probability of spontaneous emission is called A221, into N2 into del T into del T. This is how we can write the energy equation. That is the spontaneous transitions NSP taking place in a medium during the short duration of time del T is given by NSP is equal to A2 to 1 N2 del T. N2 is number of atoms in state E2, right? And del T is nothing but time difference. Here short duration of time A2 to 1 we have seen as a probability of spontaneous emission. Now, my dear students, let us understand the stimulated emission. Now, here, after absorption, we have seen there may be a spontaneous emission or stimulated emission. So, here we will understand the stimulated emission. Let us say this is a higher energy level E2 and here lower energy level E1. Now, after absorption, the atom is in higher energy level, that is E2. And my dear students, here naturally, after 10 to the power minus 8 seconds, automatically this atom will move towards the lower energy level, and such type of emission is called spontaneous emission. But my dear students, here for stimulated emission there is no need to wait for this 10 to the power minus 8 seconds also. Before this also we can start emission, and this is given by Albert Einstein in 1917. And now my dear students, what we are doing here in this process, now we are supplying here the energy of photon to the high level energy only. In this atom already excited to go back to the E1, but here before natural travel we are supplying here energy of photon, which is nothing but h mu. This energy of photon is supplied here. Now because of this energy of photon, now this atom will get higher energy, therefore this atom will travel from high energy to the low energy, will jump into the low energy zone, right? And during this process, my dear students, here the photon will emit. Here this photon is having energy difference of E2 minus E1. The energy of photon supplied is having energy difference of E2 minus E1, this energy difference. And during this emission, here one photon is emitted. This emission is nothing but radiation emission is in the form of photons having the energy of h mu, right? And also my dear students, this photon is also going forward. Means this both photon, this supplied photon and emitted photon will go forward, but while going they will go in same wavelength. It is observed that they are going in same wavelength with same frequency, right? Here they are going with same wavelength as well as same frequency nu, right? Now my dear students, and it is seen that they are moving in parallel paths. They are moving in parallel paths, and the motion is not scattered, means motion is focused. We can say it is a monochromatic emission, as well as we can say it is a coherent. It is a coherent. This concept we have seen in previous lecture, that is introduction to the laser light. In this concept we have seen this coherent principle, right? And also we have seen monochromatic emission, straight line path also, right? And such type of light is called laser light. Such type of light, focused light traveling in a path, parallel paths with the same frequency and same wavelength, and the coherent nature is called laser light, right? So my dear students, laser light is not scattered like other lights, such as X-ray light is a scattered light, laser light is not scattered light. Now if I want to write here the energy balance or atom balance, see here the number of atoms in the higher energy level, that is excited level, are A star. Now here for this A star we are supplying photon of h nu, right? Now is equal to, now here the number of atoms in the lower energy level, that is lower orbit, is nothing but A plus. Now how many emitted? There are two emitted, therefore two photons are emitted, therefore 2h. This is the energy balance. This will be the atomic balance also, we can say, right? This equation, this condition will follow. Now my dear students, again the number of stimulated transmission, here it is called forced transmission. Such type of transmission is called forced transmission, or also called stimulated. Force means stimulated transmission with the help of the energy of external photon, which is supplied to the electron or atom in the higher energy level to get emission, is called forced or stimulated emission. Now my dear students, again let us say the number of stimulated emission NST, the number of stimulated emission NST in a very short duration of time del T is need to be calculated. This NST is nothing but is equal to B221 into N2 into Q into del T. This is the balance equation. Now this NST is nothing but the number of stimulated transmission NST occurring in a material during time del T. Now B221 is the probability of stimulated emission. This is the probability of stimulated emission. Now N2 and Q and del T already we have seen in previous lectures, right? N2 is number of atoms at energy level E2, right? That already we have seen, right? Now, my dear students, so after understanding of this basic emission, that is one is spontaneous emission and other is stimulated emission, we'll need to understand the difference between spontaneous and stimulated emission for the question point of view. Now each and every point that I have discussed up to now, as well as the difference is very much important for your examination. So let us write down heading the difference between spontaneous emission and stimulated emission. Now here, very first difference between spontaneous emission and stimulated emission is that now spontaneous emission is a natural process. We have seen it is an atomic process, that is natural process. Always the atom is trying to travel from high energy level to the lower energy level naturally. But here, in case of stimulated emission, we have given the external energy of photon for the emission. Therefore, it is a artificial or forced process, right? And this spontaneous emission is a scattered, that is, it cannot be controlled. But stimulated emission is a straight line path, that is coherent, that is monochromatic, means it can be controlled very effectively. And my dear students, in case of spontaneous emission, you have seen now whatever may be the energy released, the same amount of energy photon is traveling from the outside, that is emission. Therefore no multiplication of photon takes place. But in case of stimulated emission, we have seen if I provide one photon energy to the atom, then there will be a two photon emission, means if I provide one, there will be two emission. If I provide two, there will be four emissions, means multiplication of photons takes place. And my dear students, this spontaneous emission is a ordinary light, therefore it is not useful for laser. And this stimulated emission is a useful for or essential also for the laser. Now here you can see the emission from this bulb is the effect of ordinary light. Such type of light is ordinary light, which comes under the category of effect of spontaneous emission, scattered emission in all direction. In case of stimulated emission, this laser light, this is a laser beam through which laser light is going here, right? This is the case of stimulated emission, or effect of laser light is the effect of stimulated emission. Thank you, dear students. In next lecture, we will see the concept of population inversion.